Hi, welcome to Simple Math. I'm going to explain a second example of a medium level of proficiency about the topic multiplication or multiply polynomials. Here I have a binomial, but here we have a polynomial, right? So we have to multiply term by term. And at the end, see we can combine like terms, okay? So I will try as fast I can. Alright, let's start. So I'm going to multiply this times this. Positive times positive is positive. 3 times 4 is 12. So I'm going to write here 12. X and x2 is x3. Y and y is y squared. Alright, now I'm going to multiply this with this. Positive times positive give me positive. So plus 3 times 5 is 15. 3 times 5, 15. X times x, x squared. Y times y squared is y cubed. Then positive times negative give me negative. And then I multiply. Yes, remember this is the line. And then I'm going to multiply 3 times minus 7, which is minus 21. X and x, x squared, y, and y is y squared. Okay? And finally, I'm going to multiply this one, with the last one. Positive times positive give me positive. So this is positive. 3 times 6 is 18. 3 times 6 is 18. X and x2 is x cubed, y. And then I'm going to do the same thing, but with the second term of the binomial. So I'm going to change the color. So 2x, so I'm going to multiply this times this, alright? Positive times positive give me positive. So this is plus 2 times 4, 8. Yes, x and x2 is x cubed y. Of course, I have to include it in the answer. Then I'm going to multiply positive times positive. Yes, this one with this one. Give me positive. Yes. 2 times 5 give me 10. X and x squared. And of course, I have to include y2. Alright, I'm going to use this part of the board because the space is not enough. So now I'm going to multiply this with this. Positive times negative is negative. 2 times 7 is 14. X and x squared, I include the y. And then I'm going to multiply this times the last one. Alright? Positive times positive give me positive. 2 times 6, 12. X and x2 is x3. Alright guys? That's the way I multiply by using distributive property. But this is not the end of the story. We have to combine like terms in case we see. If you see there is not another family that is made by x cubed y squared. If you see we don't have this family anywhere or nowhere, right? Because this one is not the same than this one. Why? Because this is x cubed and this is x squared. They don't have the same family, so they are not like terms. So this one is alone, of course, it's alone. I will repeat it here. 12x cubed y squared. Let's see what happened with this one. This is the family x2 y cubed. x2 y cubed. Let's see, we have x2 y cubed. No, we don't have that family, so we repeat it in the answer. Plus 15 x2 y cubed. Alright? So let's see what happened with the family x squared y squared. If you see, here we have y squared, x squared, y squared, but here we also have x squared and y squared. This is a y, this is not a g. I'm so sorry, I'm going to apologize. Okay? So, Because they are like terms, we can combine. Yes? How much is minus 21 plus 10? Minus 21 plus 10 is minus 11. So this is minus 11, and remember we keep the variables x2, y2, or x squared, y squared. Let's see if we have like terms with x cubed, y. This is a y, remember. So the family x cubed, y. Uy, look, they are together. Yes! This is a like term with this one. They have the same variables and the same exponent, right? So how much is 18 plus 8? 18 plus 8 give me 26. 26 x cubed y. Remember, when we add and subtract, we don't add the exponent. We keep them like they are. Okay, what about this family? X squared y. Do you see x squared y here? Well, I don't see it. So we repeat this in the answer. Minus 14 x2 y. And finally, plus 2x cubed. Plus 12x cubed. And here we don't have more like terms, so we cannot combine them. This is the end of the story. This is the end of the exercise. I know it's very long, or could be long, but it's not something impossible to achieve or to solve. It's just you have to take care of every detail or every step you take, and that's it. It's very easy. Guys, thanks again for watching Simple Math, and see you next time. Bye bye.